Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafizul Aiman bin Halim. I'll be presenting about our result of the experiment. So that's not much to explain because we get this result from the video of our lecturer doing the experiment. But here in the table, we have the gauge pressure, absolute pressure, pressure difference, temperature in degrees Celsius and also Kelvin, the temperature differences, and also the experimental slope. For the second table, we find the data of the pressure, temperature, specific volume, and also enthalpy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Samirul bin Baharudin, matrix number CD180194. I'm student from section 3, group 3A for engineering laboratory 4, thermodynamics. So today I will present about the observation for the set 1 report, Clausius Clayperon equation. So basically, in this experiment, the aim for student to understand the use of Clausius Clayperon equation and allows us to estimate the vapor pressure at another temperature if the vapor pressure is known at some temperature and if the enthalpy of vaporization is known. After studying the result and plotting the diagram, we find that the relation in between pressure and the temperature is directly proportional. The difference between the theoretical value and the actual value is caused by errors with certain calculated percentage. In this experiment, the relationship between pressure and the temperature is found to be directly proportional. So when compared to the theoretical slope, the experimental slope shows a small deviation between them because of certain error. So the observation that we found based on this experiment of Clausius-Clapeyron equation is the air need to be removed from the boiler. This is because we want to avoid the air from affecting the accuracy of the experimental result. For the second one is there is no error percentage should not across 10% because as the experiment was done in enclosed surface. Okay, for the third one, there are no volume of experimenting sample are allowed to escape from the system because this will cause the error to occur during the experiment. So the next one is when the water in the boiler is heated up, all of the molecules started becoming gas as the liquid absorbed enough heat energy. It changed from liquid state to water vapor. Okay, last but not least, when the temperature is rise, water undergoes evaporation and become gas. Okay, so for the last one is the water temperature increase, which resulted the pressure also increase in value. That's all from me. Thank you.
Okay, now we will go into the calculation of Clausius-Clapeyron equation. By the way, I'm Muhammad Arfan from Azani and my metric number is AD180062. Okay, this is the calculation equation involved in this particular experiment. Okay, so at the top we have the list of equations, then while at the bottom we have a list of calculation when we insert the some values and we get the final data. Okay, in the first, here we have at the top we have the equation of ln p 2 over p1 equal to hft over r times 1 over t2 minus 1 over t1. Okay, and then when we rearrange the equation, we get the hfg, which is the enthalpy of fg, which is the formula is r ln p2 over p1 over 1 over t2 minus 1 over t1. Okay, then the next formula is dp over dt equal to hfg over temperature Vg. So for the value of R here, we have 0.4615 kilojoule per kilogram. And for the HFG, when we insert the values, we get 239 kilojoule over kilogram. And for the Vg, we have 0.2522 meter cube over kilogram. And for dp and per dt, we have here 8.9151 kilojoule per kilogram. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Abdullah. My metric number is CD180188. Today, for our group, the topic for me to explain is Clausius-Clapeyron equation, which is the discussion. So first of all, we will see the Clausius-Clayperon equation for the equilibrium between liquid and vapor. So the Clausius-Clayperon equation states that the relationship between the temperature of a liquid and its vapor pressure is not a straight line. If the temperature increases, the saturation pressure of the water vapor increases. So from the previous equation, we can see L is the latent heat of evaporation, which is enthalpy of vaporization, T is the temperature, and V is the specific volume of gas. Since the volume of gas is greater compared to the volume of condensed phase, so we can get V gas is bigger than V liquid. So when we apply the ideal gas equation, we will get this equation on my slide. Next, R is the universal gas constant. So when we integrated both sides, we will get ln P equal negative L times by RT plus C, which is C is constant. So based on the data we obtained, it is corresponding to the Clausius-Clayperon equation theory. This graph will indicates the pressure of water vapor will increase as the temperature rise. This is the linear relationship between ln P versus 1 over T comes from the Clausius-Clayperon equation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Syahrin bin Imran, and I'm going to talk about the conclusion and recommendation part of the Clausius-Clayperon. So for the conclusion, we can see that the vapor pressure of water were used to describe the relationship between vapor pressure and temperature. This is because vapor pressure was directly proportional to temperature. And then we can see in this experiment that water have different intermolecular force at work and also different vapor pressure. The amount of intermolecular force will affect the vapor pressure. After this experiment, we also get to know the Clausius-Clayperon equation. For this experiment also, there are some slight difference in value that obtained due to parallax error. Next, we move to the recommendation. So, to get a better result, the reader of value must have a clear eyesight and put their eyes meniscus to the reading apparatus. Next, the experiment also should be done in a vacuum condition to prevent influence from surrounding. And lastly, to get a better result, we need to do the experiment step by step.